Hello everyone, welcome to yet another session on permutation and combination. So this topic of permutation and combination I am recording for all the students who are preparing for CA Foundation exam. And for CA Foundation quantitative aptitude, there's a very important topic called permutation combination. So far in the last two sessions, I have discussed about the concept of factorial. We have discussed the concept of factorial. Okay. And after discussing the concept of factorial, I have discussed the formula of NCR and NPR. Although I have not discussed any numerical on NCR, I have focused more on NPR. So NPR basically means permutation, while NCR basically means combination. And the relation between permutation and combination is NPR is equal to NCR into R factorial. This is the relation between permutation and combination. Okay, so we have discussed about the concept of factorial. We have discussed the formula of NPR and NCR, and then going further, what we have discussed that NPR formula is n factorial by n minus r factorial. This is the formula of NPR, while NCR formula is n factorial by r factorial into n minus r factorial. So these formulas we have discussed in the class, right? So discussing the case, like imagine if there are five chairs are there. Suppose if there are one, two, three, four, five chairs are there, and five persons are there. So five chairs are there and five persons are there. So in how many ways they can sit? We have discussed the answer of this is 5 factorial or NPN or 5P5. Okay. So in the case of linear arrangement, when we have n places and if need to be filled by n people, the number of ways it can be done is n factorial way. Like similarly, imagine if I have given you the case that you have five person and you have three chair. Okay, so in how many ways they can sit? And the answer would be 5p3. Or if I give you five chair and three person, the answer would be still 5p3. Okay, so the underlying fact here, what you need to understand that in the case of linear arrangement, the formula for linear arrangement is n factorial, or you can call it as npn. In the case that you have demand equal to supply or the total person equal to total chair, like that kind of cases. Okay, the answer would be the same. But when it comes to the next concept called circular permutation, imagine in circle if you have n person and you have n chair. So in circular permutation, the number of ways that it can happen is n minus 1 factorial. You can remember that in the case of linear permutation, n person, n chair, it would be n factorial. But in the case of circular permutation, when we talk about circular permutation, in the case of circular permutation, the answer for this would be n minus 1 factorial. Okay, why n minus 1? Because in the circle, there's no starting point or ending point. Okay, so you can arrange the data or you can arrange the people if they want to sit in the circle in any possible way. There's no starting or ending point, nowhere you can direct the person. Okay, so imagine if there are five persons are there and five chairs are there in circle, number of ways they can sit would be 4 factorial way. Like imagine if I go further in exercise 5B, okay, and discussed about this concept, like for example, the number of ways seven girl form a ring, the answer would be 6 factorial. 6 factorial is 720. Okay, and so this is the logic what we use there. Okay, so like imagine if I ask you the question number two, the number of ways in which seven boys sit in a round table so that no two particular boy may sit together. The number in which the seven boys sit around the two particular boy may sit together. So here in the same case, imagine if you want to know that in the case that if two particular people want to sit together. Okay, so you can consider those two people as a single entity. Suppose here in the question number two, they have given seven person. They have given in the question that seven person are there. And out of 7%, suppose you have 5 people who can sit in any place, and then you have A and B. You have two people, A and B, who want to sit together only. They don't want to go and sit in any other place. They want to sit together. So what I can do, let assume, okay, assume let assume A and B, let assume A and B as X. Let assume A and B as X. Okay, don't consider them as a two different person. Consider that they're same person. So you have total how many people? You have 5%, and then you have X. Okay, X means A and B. So you have total 6 people. So in how many ways 6 people can sit in a circle? So the 6 people in a circle will sit in 5 factorial way. So the 6 people in a circle, 6 people in a circle will sit in 5 factorial way. 6 people in a circle will sit in 5 factorial way. Now I want A and B to be sit together. So it can be like this. It can be AB or it can be B also. So imagine if they are sitting like 7 people are there. A, B, C, D, E, F, G. These are 7 people, and you want A and B to be together. So C, D, E, F, then G, and then X. Okay, they'll sit in 5 factorial way. Okay, now this X include A and B, so it can be AB or it can be BA also. Okay, in this arrangement, X means A and B, so they can be AB or they can be BA also. So the number of ways they can sit together, it would be 5 factorial into 2 factorial way. 5 factorial is 120, 2 factorial is 2. So the answer for this is 240. Clear, everyone? Fine. Now, when we study circular permutation, since there is no starting point or ending point, so the number of ways it can be done is n minus 1 factorial. Imagine there's someone is sitting, suppose my father is sitting here. Okay, and then we have A, B, C, D, E, F, and G. Suppose 7 children are there. Okay, and the father is sitting at one place in the dining table. Father is sitting, and now the 7 children are coming to sit in the dining table. So the number of ways they would sit would be 7 factorial. Number of ways they would sit in 7 factorial way. Why? Because once the person is sitting, now you can define the position of other person based on the person who is there. And based on the host, you can define the position of the person. Initially in circular, why we are discussing as n minus 1 factorial? Because since there was no one, so you can start from any position. So imagine this is circle. So there's no starting point, there's no ending point, there's no left, there's no right. So if 5 persons are there, 5 chairs are there. So in how many ways they can sit? It would be n minus 1 factorial. Once the first person is set, then you can define the position of other person based on the first person. And for the first person, all positions are identical. Okay, I hope you have understood. That's why it is n minus 1 factorial. In the case when you are doing these kind of cases, and if you are any kind of cases like necklace kind of problem, okay, necklace kind of problem, there clockwise or anti-clockwise does not matter. So the number of ways how it can be arranged, the number of ways how you can arrange the flower in the garland or beads in the necklace. Okay, it would be n minus 1 factorial by 2. So like flowers in the garland, flowers in the garland, or beads in the necklace, or beads in a necklace, it would be done in n minus 1 factorial by 2. Okay, it would be done in n minus 1 factorial by 2. So like uh, if you see this, yeah, question number 3. If 50 different jewels can be said to form a necklace, number of ways it would be done in option B, 49 factorial by 2. Okay, I hope you understood this. Now, going further, question number 4, if we discuss, question number 4, 4, 3 ladies and 3 gent can be seated in a round table so that any two and only two of the ladies will sit together. The number of ways it can be done in. Okay, let me just take the screenshot of this. Okay, so 3 ladies and 3 gents are sitting in a round table so that any two means out of 3 ladies, you can select any 2 ladies. Out of 3 ladies, 2 ladies are selected in 2 ladies are selected in how many ways? 3C2 way. 3C2 way means 3 ways. Okay. So you can select 3 ladies out of from 3 ladies. You can select the 2 ladies in 3 ways, 3C2 ways, or 3 ways you can select. Okay. Then from 3 ladies, you can select any 2 ladies. Suppose those 2 ladies you got are A and B. Okay. Then what they're telling, can be seated in a round table so that any two and only two of the ladies sit together. Okay, so these A and B, they are sitting together. You want A and B, A and B, you want A and B to be sit together. Okay, you want A and B to be together. Okay, so I've selected the two-person and that I can do in 3C2. Now A and B, suppose you make it X. And suppose 3 ladies are A, B, and C. Okay, so we have 3 male M1, M2, M3, and then you have X, and then you have C. In the question, it is given that only two will sit together. Means here it is given that X and C should not sit together. Okay, X and C should not sit together. So let first make the male to sit M1, M2, and M3. So the 3 males will sit in how many ways? They will sit in 2 factorial way. So 3 males in a circle will sit in 2 factorial way. Okay, now we have place for X and C to sit. They can sit in any of these 3 places. Okay, if X and C any of the 3 places, they can choose to sit. The X and C would not be together. Okay, so this would be 2 factorial, and these X and C can sit in how many ways? 3P2 way, and you can select A and B in how many ways? 3C2 way. Okay, out of 3 ladies, you have selected uh, A and B together, which they will sit together in 3C2 way. Now A and B within themselves, what they can do, they can interchange their place in 2 factorial way. So the answer for this would be 2 into 3C2 means 3 into 2 means 6. 3P2 is 6. 3C2 would be what? 3 C2. What is 3C2? 3. And then 2 factorial would be 2. So the answer for this is 12. 12 into 6. 12 into 6. The answer for this would be 72 ways. So the question number 4. The answer for this would be 72. Okay, then question number 5, the number of ways in which the letter of word dogmatic can be arranged. So here this would be when you talk about dogmatic, it is what 11th, sorry, 8 letter word DOG MA5 T6 IC7, 8 letter word. So it how many ways you can arrange it? You can arrange in 8 factorial way. So option B. So the number of arrangement of 10 different things taken 4 at a time. Okay, so from 10 things you have to take 4. So that would be done in 10C4 way. But one particular always occur means it's like one would always be there. So one would be there means you have to select only 3 things from the 9 things because one is all anyway it would be there. 9C3 means 9 into 8 into 7 by 3 factorial is 6. The answer for this would be 84. Okay, so the question number 6. Okay, then okay, arrangement they are asking. So you this would selection would be 9C3. Then they are talking arranging. So you'll arrange now you got 4 things, right? You got 4 things A, B, C, and D. And you have to arrange them. They have answer. They ask if it is all about selection, then one to anyway would be there. So suppose A anyway is there. So you have to select from the 9 things, you have to select 3 things because one would always be there. So you got the four things. Now these four things you can arrange in how many ways? 4 factorial way. 4 factorial is 24. So 84 into 24. So multiply 84 into 24. 84 into 24. 24 fours is 96. And 96 twos is 192. And this would be 1911 10 2016. Answer is option B. Now the number of permutation of 10 different things taken 4 at a time in which one per never occur. So now this again permutation. Okay, so one particular thing never occur. So from 10 thing you have to take 4 thing and one thing should not be there, means A should not be there. Means from 9 object you have to choose 4 object and then you arrange this 4 object in 4 factorial way. Okay, one should not be there, so A should not be there. So from remaining 9 things, you have to select 4 things, 9C4. The 9C4 means 9 into 8 into 7 into 6 divided by 24 into 24. So this get cancelled. So this is 72 into 42. So 72 into 42 if you do in your CA exam calculator is allowed. So you can do with calculator. Okay. 72 into 42. This is if you solve it 4, 12, 3024. Answer for this is 3024. 3024. Seventh, the answer is option C, 3024. I hope you have understood this. Now, going further, if you try this question from 8 to 11. Now, see this question number 8. Mr. X and Mr. Y enter into railway compartment having 6 vacant seat. Okay, number of ways that they can sit is that 6 vacant seat is there. So X can sit in any of the 6 places. Then Y can sit in any of the remaining 5 places. That would be option D, 30. Clear everyone? Then we can read the next question. Okay, so the number lying between 100 and 1000 that can be formed using the digit 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So you want to make a 3-digit number. Okay, and the number of so between 1 to 1000, no 4-digit number, only 3-digit number. So you have total 7 digits, and from 7 digits, there's no restriction. You have to choose any 3 digits and you have to arrange them in 3 factorial way. 9C3 into 3 factorial, it would be 9P3. 9 into 8 into 7. 72 into 7. 72 into 7 is 504. Okay, 9 into 8 into 7. Yeah, 72 sevens. 504 should be the answer. 7P3. 9, sorry, 7. No, you have written 9P3. Right. So the answer is 7P3. 7 into 6 into 5. So this would be 7 into 30, means 200 then. Okay, the number lying between 100 and 1000 with the digit. Now if 0 is there, then 0 cannot come in 100 place. So 2, 3, 4, 0, 8, 9. So okay, so here 0 cannot come in unit place. Remaining any digit can come here. So 100 place 0 cannot come. So 1, 2, 3, 4, 5. Any 5 digit can come here. And then you cannot use 0. Now you have 1, 2, 3, 4, 5. Out of these 5 digit, any digit can come here. Any 4 digit can come here. So the answer for this is 25 fours are 100. 1 minute. So the number of, okay, sorry, I have not seen. Okay, 234,089. The number line between can form. So, okay, sorry, 10 is there. I just seeing only 100, 2000, I was thinking. So 10, 2000 they have given. So two-digit number also we can make. So talking about two-digit number. So zero cannot come here. So 1, 2, 3, 4, 5. Except zero, any 5 digit can come here. Now, including zero, remaining any 5 digit can come here. So two-digit number you can make is 25 two-digit number. Now, when it comes to three-digit number, how many three-digit number you can make? Again, zero cannot come in 100 place. 1, 2, 3, 4, 5. Any 5 digit number can come here. Here, any four, any including zero, remaining any 5 digit number can come here. Here, any 4 digit number can here. Digits cannot repeat. So 25 into 100, 25 into 4 is 100. So the total number you can make is 125. Okay. So question number 9, the answer was 210. Okay. So 1, 2, 3, 4, 5, 6, 7, 7 digits were there. And out of the 7 digit, you have to make any 3 digits. So it would be 7p3. There's no restriction, anything. But here zero cannot come in two-digit number. Zero cannot come in the 10th place, while in three-digit number zero cannot come in 100th place. So in two-digit number, if zero cannot come in 10th place, so we have remaining 5 digit 2, 3, 4, 8, and 9. Any digit can come in 10th place out of these 5 digits except zero. Then in the ones place, like you whatever digit you use, you will not use the digit. Now you have 5 digit left including zero. So you can make 25 two-digit number, and similarly you can make 100 three-digit number. So the answer it will be 125. Now question number 11. In a group of boys, the number of arrangement of four boys is 12 times the number of arrangement of two boys. Okay, the boys in the group is, so this is NP4, n into n minus 1 into n minus 2 into n minus 3 is equal to 12 into np2 means n into n minus 1. So this would be n minus 2 into n minus 3 is equal to 12. 12 means 4 into 3. So means n here would be 6. Question number 11, answer is option C. Okay. The going further, if we see the question from 12 to 17, if I see the question from 12 to 17, so remember this here, what they're asking us, question number 12, it is like it's going, R is going from 1 to 10. It is like R is 1, 1 into 1 factorial plus 2 into 2 factorial. Okay, NPN is nothing but n factorial. I can write it like this. Okay. So RPR, instead of RPR, I can write R factorial, right? So here they are writing like R into RPR. So this is nothing but R into R factorial. Clear everyone? RPR, when you're saying RPR, so RPR is nothing but R into R factorial. Okay. And this R is going from 1 to 10. Okay. So means in this question number 12, it is like this: 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial till it will go till 10 into 10 factorial. Okay, this is like this. So you can remember the formula for this. So for n terms, this is like answer is n plus 1 factorial minus 1. So the answer for this would be 11 factorial minus 1. This would be your answer for this question. Means 11p 11 minus 1. Okay, this is a formula in the term of n term. Otherwise, if you want to prove this, okay, what you can do is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus 4 into 4 factorial. So 1 into 1 factorial 1, 2 into 2 factorial 2, 3 into 3 factorial is 6, 4 into 4 factorial is 24. So 1 plus 4 plus 18 plus 96. 96 plus 4 is 100. 100, 118, 119. 119. 119 is nothing but 5 factorial minus 1. This is what I was trying to say. So if you are going till n factorial, n into n factorial, the answer for this would be n plus 1 factorial minus 1. Okay, so you can take any number. If you go till 5 into 5 factorial, the answer would be 6 factorial minus 1. So this is you can remember. Then question number 13, the total number of 9-digit number of different digits. So 9-digit number you are making of different digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total we have 10 digits. Okay. Uh, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 cannot come here. So any 9-digit can come here and digit cannot repeat. So including 0, now you have 9 digits. Any 9-digit can come here, then here any 8, then here any 7, then 6, then 5 into 4 into 3 into 2. So the answer for this is 9 into 9 factorial. Option C. 13th your answer is option C. 14th, the number of ways in which 6 men can be arranged in a row such that 3 particular men sit together. So 3 particular men make it X, and then you have 3 or more left, A, B, and C. So in how many ways you can arrange them? 4 factorial way, and the 3 people within themselves will sit in 3 factorial way. So this would be this you can 4 factorial I can write as 4p4, and 3 factorial I can write as 3p3. The answer for this would be option B, 4p4 into 3p3. Then question number 15, there are 5 speakers. Okay, A, B, C, D, E, the number of ways in which A will speak always before B. So A and B always before B. So fix it A and B and make it X. And then they will not interchange the place. So you have C, D, E, and X. In how many ways they can arrange the place? 4 factorial way. 4 factorial is 24. And in that A and B will not interchange the place because A in any case the A should be speaking before B. And so X is like AB. It's not AB BA. It's AB only because A should be before B. Question number 16. There are 10 trains between Calcutta and Delhi in which a person go from Calcutta to Delhi. He can go in any of the 10 train, and whatever train he has gone, he will not come back by the same train. The answer for this would be option B. Question number 11, question number 17, the number of which 8 suite of different sizes can be distributed among 8 persons of different ages so that the largest always go to the smallest. So give the largest to the smallest. So now you have 7 suite and you have 7 person. So in how many ways they can eat? 7 factorial or 5040 ways. Clear? Now question number 18 and 19. So the number of arrangement in which the letter of word Monday arranged so that it should always begin with M. 1, 2, 3, 4, 1, 6, 1, 2, 3, 4, 5, 6. Okay, should always begin with M. So there's no arrangement beginning with M, and it should not end with N. It should not end with N. So how many letters are left? O, D, A, or Y. Any of the four letter can come here. Okay, this is fixed. So now you have what, four places and four letter, and you have four places and four letters. So four places, four letters, they will come in 4 factorial way. So the total number of ways this can happen is 4 factorial into 4. 4 factorial is 24 into 4. It would be 96. Question number 18. The answer is option C, 96. Question number 19. The number of ways in which 6 plus sign and 4 minus sign are arranged in a line so that no two minus sign come together. No two minus sign come together. Number of ways in which 6 plus sign arranged in a line. Okay, so the number of ways in which 6 plus sign, if I write 1, 2, 3, 4, 5, 6, 6 plus sign, if I'm writing here 1, 2, 3, 4, 5, 6, 7. So minus can come in any of the four place. Now if I'm arranging 6 plus sign, okay, if I'm arranging 6 plus sign here, so what we need to understand in the case of here is that you're putting 6 plus sign, and that you can arrange in how many ways? You can arrange in 6 factorial ways. Okay, so this plus sign, you can write them together and all are identical only. So you can they will interchange their place in how many ways? 6 factorial by 6 because all are same thing. So they would be identical. 6 plus sign, if you are trying to arrange, so all are identical. So the answer for that, it would be one way. You put any plus sign where anywhere doesn't matter. Okay. Then because of them, there are seven spaces created where the minus sign can come. 4, 5, 6, 7. Out of 7 place, any place the minus sign can come. You have 4 minus sign only. Okay, so I have 4 minus sign only. So from the 7 places, I can choose any 4 places. And in these 4 places, 4 minus sign will come and all looks identical. So it doesn't matter which is is putting where, doesn't matter, all looks very identical. The answer for this would be 7C4. That is the answer. 7C4 is 7C3. 7C3 is is 35. The answer for question number 19 is is 35, option C. Question 19, the answer is option C. Then we have two question left. The number of ways in which the letter word mobile arranged so that always the consonant occupy the odd places. So mobile, how many vowels are there? How many vowels are there? O, I, E. Total three vowels, and how many consonant are there? M, B, L. Okay, M, B, L. So here, 1, 2, 3, 4, 6 letter word. Consonant always occupy the odd places. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6. Three consonant, three places. They will come in 3 factorial way. Then three vowels will come in 3 places in 3 factorial way. So the answer for this would be 36. 3 factorial into 3 factorial. Question number 21. 5 persons sit in a round table such that a taller person is always right of the shorter person, shortest person. So you fix the place of taller and shorter together. So you have 3 person plus taller and shorter. Okay, so you have now 4 person. Now 4 person will change the place in 3 factorial way. 4 person would change the place in 3 factorial way. Okay, so uh, 3 factorial way, it means what? 6 ways. Okay, so the number of ways it would be done in 6 ways. And also taller person is always right, so they cannot interchange the place. Okay, now we have 4%, and these 4% will sit in basically here we have 3% plus taller and shorter together. So when we talk about taller and shorter together, so in how many ways now we have 4 people, and 4 people will sit in circle in how many? 3 factorial way. 3 factorial means 6. Clear, everyone? So with this, I have ended this exercise. Exercise was all about circular permutation, and and I hope you found this exercise very easy. Thank you, everyone. I'll see you all in next video.